A sample of 10 men was used in a study to test the effects of a relaxant on the time required to fall asleep. Data for 10 subjects showing the number of minutes required to fall asleep with and without the relaxant is as follows. Without the relaxant, 15, 12, 22, 8, 10, 7, 8, 10, 14 and 9. With the relaxant, for the same 10 men, 10, 10, 12, 11, 9, 5, 10, 7, 11 and 6. Use a 0.05 level of significance to determine whether the relaxant reduces the median time required to fall asleep. So we'll do an upper tail Wilcoxon signed rank test, where the null hypothesis is that the median without the relaxant minus the median with the relaxant is less than or equal to 0, versus an alternative hypothesis that the median without minus the median with is greater than 0. And if that alternative hypothesis were to hold, that would indicate that the relaxant reduces the median time required to fall asleep. The first step in the calculation is to calculate the differences in the time required to fall asleep for each subject. And we can see that there are 8 positive values there for which the relaxant does appear to reduce the time required to fall asleep, and there's 2 negative differences for which the time required to fall asleep using the relaxant has actually increased. So overall it does look like the relaxant is working, but do we have significance here? Do we have enough evidence to conclude that the relaxant works? So the next step is to calculate the absolute values of those differences, and then we assign ranks to the absolute values of the differences. So we look for the smallest absolute difference, and that is given the rank 1. And then the next smallest, it looks like there's 3 2s. So the average rank of those 3 2s would be 3. And then we've got 4 3s, and the average rank of those 4 3s would be 6.5. And then next we have a 5, and that has rank 9, and then finally the largest absolute difference has rank 10. Next we look back at the signs of the differences and assign those signs to the ranks. So we'll have 2 negative ranks and 8 positive ranks, and if we add up the positive ranks we get 45.5. Next, we need to calculate the mean and the standard deviation for the normal distribution that we'll use to figure out the p-value. And the mean comes to 27.5 and the standard deviation comes to 9.8107. And then we have to calculate a p-value, and it will be an upper tail since we're doing an upper tail test. And the only thing we have to remember is to apply a continuity correction. So instead of using 45.5 in our formula, we'll correct that to 45, and then subtracting the mean and dividing by the standard deviation we get 1.78, and the tail area to the right of 1.78, if we look up a standard normal table we can find the area to the left of 1.78 comes to 0.9625. So therefore the area to the right would be 1 minus that, which comes to 0.0375. So that's the p-value for our test, and since it's less than our significance level alpha, we reject the null in favor of the alternative, and so there is evidence that the relaxant reduces the median time to fall asleep.